Hello students, today we will be studying potential energy of a system of charges. Now there are two charges, we have taken two charges, one we have named Q1 and one we have named Q2, and they are separated by a distance R1. Now initial potential energy we have taken as EY and final potential energy we have taken as EF of the system. Now let these two charges Q1 and Q2, when they are separated by distance R1, at that time due to their configuration, let the potential energy is equal to UI or U1, you can take whatever it may be. Now if these two charges are separated by a distance, that means the distance between them is increased to R2, then the configuration of potential energy becomes UF or R2. Now let the separation at any such instant is equal to R. Now if we keep the positions of Q1 fixed, then Q2 is displaced by dr. So work done due to this displacement dr is dWe is equal to F vector dot dr vector. So work done due to this displacement dr is dWe is equal to F vector dot dr vector. Now see Q1 and Q2, they're separated by a distance R. Now this dr vector, direction of dr vector, and the direction of the electric field, so both are in the same direction, so angle between them is theta, and the value of theta here is 0. Therefore cos theta is equal to 1. Now we know work is equal to F d cos theta, where force, displacement and product is three things multiplied. So F is equal to, as we know, K into Q1 Q2 by R square, where K is 1 by 4 pi epsilon 0. If we put by value of F is equal to 1 by 4 pi epsilon 0 Q1 Q2 R square and cos theta is no 1, and integrating this, we get work done is equal to Q1 Q2 by 4 pi epsilon 0. It is constant, it is come out from the integration, and after necessary integration we have seen the r to the power minus 2 dr, its value ranges from R1 to R2. Simply integration of x to the power n dx is equal to x to the power n by plus 1 divided by n plus 1. Now the range, after integration we have put the range from R2 to R1. This gives you the value Q1 Q2 4 pi epsilon 0 within bracket 1 by R2 minus 1 by R1. Now from definition we know that potential energy is equal to the minus of the work done, since it takes place in the opposite direction. Now del U is equal to final potential energy minus initial potential energy is equal to minus WE. Therefore UF minus UI is equal to Q1 Q2 by 4 pi epsilon 0 1 by R2 minus 1 by R1. Now if we take the infinity as the reference point, then R1 is equal to infinity, and UI or the UN means initial potential energy becomes 0. So final potential energy, you can take UF or U2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R2. Therefore U is equal to, we can write 1 by 4 pi epsilon 0 Q1 Q2 by R. And this is the generalized form. Now if we write Q1 Q2 greater than 0, we know if Q1 Q2 greater than 0, then potential energy is positive, because for like charges Q1 Q2 greater than 0, Now, electrostatic force is repulsive here. Thus, positive work must be done to overcome these repulsive forces. Okay, to bring the charges from infinity to a finite distance. Now, if Q1, Q2 for the second case less than 0, then U is negative. So, electrostatic force is attractive force. Thus, positive work must be done to take the charges from the given finite location to infinity. Thus, negative work is required in the reverse path. Okay. So, if you like my video, give a thumbs up. Thank you.